Hey everybody, really quick, thanks to everybody that stopped in on that Google Meet. It was a definite learning experience for that, but more importantly, thank you for your questions because it helps me figure out what I can do to help support whatever we're doing in class and clear up any issues, which is the point of this really quick video. So just a couple things that have come up through emails and through that Google Meet. So first of all, an ohmic resistor, keeping it simple, ohmic resistor, the resistance stays constant. That's it. Stays constant. That's all. So you should know by now that the slope of the velocity versus, velocity, the voltage versus current graph was linear in your lab, and that means the resistance is constant since the slope is resistant. So if it's not linear, it's not constant. And for any problem you do, if it asks for the resistance at this voltage and the resistance at this voltage or current, and they're different, it's not ohmic. If they're the same, it's ohmic. So that's what it means to be ohmic. Now, a couple other things. There's a question that asks about energy when you get to the power homework. So what we should remember is power is work divided by time, but work is also a change in energy. So technically, power is energy over time, because again, it's supposed to be a delta T, work is a change in energy. So if you can solve for the power, you can get that the energy is simply power times time. That's all. That's not a big deal. All right, what else? Somebody had asked about the problem where it says number of electrons. I'm not going to do the exact problem, but for that problem, I believe we're given V and we're given R, so we can get I. I, we know, is charge, whoops, that's supposed to be a charge, Q over delta T, which must be in seconds. Please remember that for both of these. They have to be in seconds. And so afterwards, we can get the charge, and that's measured in coulombs. That's the total charge. And each electron has a charge of 1.6 times 10 to the negative 19th. It's like saying you have 100 cents. Each quarter is worth 25 cents. How many quarters do you have? So you're, how many quarters do you have? So you're basically taking that and dividing by 1.6 times 10 to the negative 19th coulombs. And then one last thing, there's a problem in the power homework that says how much does it cost to run stuff? So this is interesting because they do energy, which is measured in kilowatt hours. That is not kilowatt per hour, it's kilowatt times hour. So basically, coming up over here, let's change colors for fun. All right, so we already have that energy is power times time. Now this is measured in watt seconds, but that's not how we need to measure it. So we need to convert watts to kilowatts. So we need to make watts into kilowatts. Kilo means 1,000. And we need to convert seconds into hours. So step one is to solve for the energy, but you have to make sure the power is measured in kilowatts and the time is measured in hours. Then you're actually multiplying kilowatts times hours. Then after that, we're going to take that and multiply by the dollars per kilowatt hour. So basically just looking at unit conversion here, you have energy, which is again measured in kilowatt hours. And we're going to multiply that by the dollars per kilowatt hour. And what will happen is the kilowatt hour will divide out, and the only thing you're left with is dollars. So I hope that clears up any issues. I don't want to make this video long. I hope you read the email. And please know, you can contact me anytime through email, and I will get back to you. Trying to make this as best we can and trying to keep the education going with some form of a standard And I just hope you're all doing okay. At the end of the week, I'm going to need to know how this week went in physics for you, so I know if we should continue in this method. Anyway, stay safe, get outside. It's going to be beautiful on Friday. Enjoy the weather, and hope you're well.